Welcome to my channel Learning with HBB. In this tutorial I am going to cover multi-stage graph. A multi-stage graph G is a directed graph in which vertices are partitioned into sets. For example, this is the multi-stage graph. We are going to partition this graph into stages. For example, this is the stage 1, this is the stage 2, this is the stage 3, this is the stage 4. That is, it is the first stage, it is the second stage, it is the third stage, it is the fourth stage, and it is the fifth stage. And we are going to find the minimum cost path such that we have to take decision at each of the stages through dynamic programming. First of all, let's go through the input is a k-stage graph with n vertices indexed in the order of stages. That is, in this graph we are going to divide this graph into stages, into k stages, that is k is equal to 5, that is we are going to divide it into 5 stages, and then the vertices are indexed in the order of the increasing number of stages. For example, first stage will contain vertex number 1, second stage 2, 3, 4, 5, 6, 7, 8 is in the third stage, and similarly for the rest of the stages. Such that Cij is the cost of edge ij, Pik is the minimum cost path which we have to find out. First of all, cost of n is equal to 0, that is we are going to begin this algorithm from the last stage and then we will return to the first stage by calculating the minimum cost path in each of the stage. Now in this case we are going to calculate from the last edge, that is cost of n is equal to 0, which in our case is equal to 12 because we have 12 vertices. So cost of 12 is equal to 0, and now we will decrease the vertices in the order of their indexes such that we have to find a vertex in each of the stage such that jr is an edge and cjr plus cost of r is minimum. And next we have to add that into the array d of j, which will ultimately be useful for calculating the minimum cost path. Now let's begin the example. As according to the algorithm, cost of n is equal to 0, that is cost of this is equal to 0. Let's write it down. I have to decrement the loop, for loop, from j minus 1 to 1, that is 12 minus 1 is equal to 11. So we will start from the vertex number 11 to calculate our minimum cost path. We will have to find a vertex r such that jr is an edge of g. That is, in this case r is equal to, if I choose vertex number 11 according to the loop, then r is 12. So therefore cost of C of jr, that is 11, 12 is equal to 5. That is cost of 11 is equal to C of 11, 12. C of 11, 12 plus cost of r, which in our case is equal to, where r is equal to 12. So cost of 12 is already 0. Therefore C of 11, 12 plus cost of 12, which is equal to 0. Now the cost of 11 is equal to 12. I am going to mark it. Therefore cost of 11 is equal to 5. and we are going to add that path into our path matrix, which is d of 11 is equal to 12. That means the shortest path from the 11 is goes from 12. Now for the next case, now for j is equal to, now loop for j is equal to 11 has been completed. Now it has been decremented, and we will now find for j is equal to 10. Now for j is equal to 10, c of jr is equal to 2 and r remains the same, that is cost of r is equal to 0. Therefore the total cost of 10 will be equal to 2. Similarly, total cost of 9 will be equal to 4. I am not going to go in detail of this, as I have already expressed in this way, that is cost of 12. Similarly, you can overwrite it with this. Therefore cost of 11 is equal to 5, cost of 10 is equal to 2, and cost of 9 is equal to 4. Now let's do it a little bit faster according to this formula, which represents the same meaning as provided in the algorithm. Cost of 8 is equal to c of 8 10 and c of 8 11. That is, we are going to choose here the r is, for the first case it is equal to 10, and for second case it is equal to 11. So we have to calculate the minimum between the two, that is c of, here r is equal to 11 for the first case and r is equal to 10 for the second case. Now we have to calculate the minimum of C811 and C810, including its cost of that particular R, which is cost of 11 and cost of 10 as per the algorithm. And now our answer is equal to 7. Now similarly, we have calculated the cost of 6th, 7th and 8th. For 8th, there are two vertices, vertex number 10 and vertex number 11. Out of these two we have to choose only one, so we are going to choose it from here, just like cost c of 811 plus cost of 11 and c of 810 plus cost of 10. Out of these two the minimum is 7, and that minimum cost is achieved by traversing through the path 10. So we have write d of 8 is equal to 10. Similarly, cost of 7 is again 10 and 7, 9. Out of these two we have to choose only one. So 7 10 and 7 9 plus including the cost of 10 and 9 into it, we have got minimum cost is equal to 5, and that minimum cost is again achieved by vertex number 10. So we have write d of 7 is equal to 10 in the D matrix or the minimum path matrix. Similarly for the 6. Now we have reached to stage number, if I mark it stage number 1 2. Now we have reached to stage number 2, and we will calculate the same cost using the formula as given below, as we have calculated previously. Similarly, cost of the stage 2 can be calculated by using the same formula as we have done previously, that is cost of, we have to find the cost of 2, cost of 3, cost of 4 and cost of 5. Now for 5 we have again two vertices, that is vertex number 7 and vertex number 8, out of which we have to choose. For vertex number 4 we have only one vertex, which is vertex number 8, so obviously this will be the shortest path. Similarly for 3 there are again two vertices, vertex number 6 and vertex number 7. For vertex number 2 there are three paths, that is from to the path to the vertex number 6, to the vertex number 7 and to the vertex number 8. That is for 4 we have only one vertex, for 3 we have two vertices, and for 2 we have 1, 2 and 3. We have 3 vertices of which the minimum distance is to be calculated. Correspondingly, we have also made the D array, which defines the minimum cost or stores the path of the minimum cost. Now we will calculate the minimum cost from the first vertex, that is vertex number 1, and the decision will be taken in the first stage of the multi-stage graph. Again, the same approach will be followed, that is we have to now calculate the shortest distance from 1 to 12. Let's calculate the distance between the vertex number 1 and the shortest distance, which can either be through 2, 3, which can either be through 2, 3, 4 or 5. To calculate this, we again use the same formula as we have done earlier, that is cost of 1 is equal to minimum of C12, C12, C13, 14, 15 and its minimum cost of 2, 3, 4 and 5, and that comes out to be cost of 2, and that comes out to be cost of 1 is equal to 16, and d of 1 is equal to 2. Now let us find out the total path of this multi-stage graph. As we know that we have saved that path into the D matrix, into the D array or D matrix like this, that is d of 1 is equal to 2. We have taken this from here, d of 1 is equal to 2, d of 2 is equal to 7, d of 3 is equal to 6, d of 4 is equal to 8, d of 5 is equal to 8, and so on, just like this. And from here we can reduce the path. But before doing this, let us go through the rest part of the algorithm. That is, first of all, we are writing here p of 1 is equal to 1 and p of k is equal to n. It means that the first vertex or the source vertex from where we have begun is 1. So our first path will start, shortest path will start from 1, and the last vertex that will end up to 12. So these are prefixed because these are already known. Now the loop will continue from j is equal to 2 to k minus 1, and we have to calculate this distance. We have to calculate this matrix from the D matrix, such that p of j is equal to d p j minus 1, which is equal to, now suppose for j is equal to 2, p of 2 will be equal to, p of 2 is equal to d of p j minus 1. J minus 1 means 1. So p of 1 we know, p of 1 is 1. So it is equal to d of 1, and d of 1 we can easily take from graph, that is d of 1 is equal to 2. So our first will be from 1 we have to go to 2, followed by from 2 we have to go to 7. We have to go to 7, and from 7 we have to go to 10. From 10 we have to go to 12. So our final multi-stage graph will have this shortest path, that is from 1 to 2, 2 to 7, 7 to 10 and 10 to 12. That is 1 to 2, this will be the shortest path. From 2 to 7, this will be the shortest path, and from 7 to 10 and 10 to 12. So this is our complete shortest path of this multi-stage graph, which we have calculated from the dynamic programming algorithm. Now let's take again a look by taking another example of this multi-stage graph, which is this stage. Again we are going to divide it into stages: stage number 1, stage 2, stage 3 and stage 4. Again we have to begin from the last vertex, and cost of last vertex or cost of 9 is equal to 0, and then we will back trace, that is we will take 8 into account, then we will take 7 into account. Obviously the cost of 8 is equal to 3 and cost of 7 is equal to 7, as it is clear from the graph. Otherwise you can put it into this formula and the results will be same in both the cases. Now As we have now reached 4, 5 and 6, we have two cases for each. For 4 we can either go to 7 and to 8. Similarly for 5 either 7 or 8, and for 6 also either 7 or 8. Let us do this by applying this in the formula and solve it. That is, cost of 4 is equal to minimum of C47 and cost of 7. Also C of 48 plus cost of 8. Out of these two we have to choose the minimum, and which in this case is calculated by this. So the minimum is equal to 7 and cost of 4 is equal to 7, and we have added that into the D matrix by using. Now similarly, cost of 5 is equal to C of 57 plus cost of 7 and C of 58 plus cost of 8. Now we are going to implement it with this formula, that is cost C of 57 plus cost of 7, C of 58 plus cost of 8, which comes out to be 5 in this case. Now similarly for cost of 6, which is equal to either the cost of C of 67 plus cost of 7 or C of 68 plus cost of 8, and the shortest path will be reached through D of 6 is equal to 8. Now for the stage number 2, we also have to apply this same formula to calculate the shortest path. Similarly, the cost of 2 can be calculated by calculating or finding the minimum between 2, 4 plus cost of 4 or 2, 6 plus cost of 6, which is calculated as 2, 4 plus cost of 4, 2, 6 plus cost of 6, and the shortest distance is reached through D of 2 is equal to 6. We have added into the matrix. Now we have to find the distance, shortest distance or the minimum path from the vertex number 1. For finding the shortest distance of vertex number 1, we have to again use this formula. For that, now after putting or calculating the cost of 1, which is equal to C of 1, 2 plus cost of 2, C of 1, 2 plus cost of 2, or it can be either C of 1, 3 plus cost of 3. By calculating the cost, minimum cost comes out to be 12, which is through the vertex number 3. Now let's draw. Now as we have calculated all the cost and the D matrix, now let us finalize the D matrix, which is as below, which is as shown, that is D of 1 is equal to 3, D of 2 is equal to 6, D of 3 is equal to 6. Now let's draw the shortest path. Now the first vertex will be 1 and the last vertex will be 9. Because it is the source vertex, it is the sink vertex, as clear it is clear from the algorithm. Now from D of 1 it is 3, so from 1 it goes to 3. From 3 it now goes to 5. So here is the fifth vertex. From fifth vertex we have to go to vertex number 8, and from 8th vertex we have to go to vertex number 9. So this will be the shortest path of our multi-stage graph. Let's draw this, that is 1, 3, 5, 8, 9. 1, 3, 3 to 5, 5 to 8, and 8 to 9. This will be the shortest path of this multi-stage graph, and the cost is given by the cost matrix which we have calculated in the last step of our algorithm. Thanks for watching this algorithm. For any doubts and queries, you can comment below. Thanks for watching.